Hello and welcome to this video about functions. Functions is another thing that you're going to be using a lot when you're programming. So let's get into it. So first, here's a very simple function. You probably also already seen something like this in DataCamp by now. But it takes one argument and returns one output. You define it using def space, and then you have the name of your function, which is whatever you want to call it. Then using brackets, you have the argument of your function, which can be multiple arguments, and then a colon, and then there's this indentation where you then have your lines of code for what the function does, basically. And then the function stops when you stop doing indentation, or if you insert a return statement. And the return statement defines the output of the function. So here, as said, the function is called f. It takes the argument x, and it returns x squared, or x to the power of 2. So if we print it, we can sort of see that it works as we expected, and returns 4 when the input is 2. Alternatively, if you have a very simple function, then you can define it using a lambda formulation. So this is actually the exact same. We just say we want to create a function called g, and we want that function to be a lambda function, or a function which takes the argument x and then colon. Then this is the return statement. This is what the function returns, and you can see that this is the exact same. It's just a different formulation. So these are shorter to write if you're just doing something that only takes one line. You'll probably also see this when you look at other people's code. So it's good for you to know. A function can also take multiple arguments. That's just putting more arguments inside the brackets, separating them by a comma. And then here we return the sum of the arguments squared. And then we see that that's 8 for 2 and 2. Which makes sense. You can also have multiple outputs. So here again we have 2 inputs or 2 arguments, and then we calculate the squares separately as z and q, and then return them separately, separated by a comma. When you do that, Python sort of automatically assumes that it returns a tuple of the elements. So this is sort of, you could also write this and that would be the same, and then you explicitly define it as a tuple. And you can sort of take out the argument as the tuple as is, and then print it, and then you can see that the class is the tuple. What we would typically do is that we want the arguments separately, and then you can just unpack them by simply writing the names of what you want to call the new variables, and separating them by a comma. So here this tuple has 2 elements, so you can sort of unpack it using 2 names separated by a comma. In practice, we would do this directly. So we would say set point q is equal to the output of the function, and then you get the exact same. So you don't need to sort of take out the tuple and then create the variables. You can just create the variables directly. A function can also have no outputs, and this can be useful if the inputs are mutable, or if you just want to make a function that prints something, or something where you don't need the information out. Typically, the print functions are also very useful, but typically you have an input, which is some type of container, and then you want to change that input slightly via the function. So this is a function which takes x, which we assume to be a list, and then we create a new element, which is just the last element plus 1, and then we append that new element to the list. And then when you do it like this, where you have an input and you change the input, then x will be changed after you run this function. So if we take a list with three elements, and we call the function on that list 3 times, then we append 3 new elements to the list. So you can see that we start with 1, 2, 3, and then we add 4, and then we add 5, and then we add 6 to the list, and then we end up with this. This can also happen when you don't intend it to happen. So you should be wary of this when you're doing operations on your arguments inside a function, that you can sort of change your arguments for the next time that you call the function. Yeah, you should be aware of it, and it can be very useful. A function can have keyword arguments. That's sort of default values that you say, okay, if I don't say anything when I call the function, then just assume that I want these values, otherwise change them. So you do that by, you can write your positional arguments first. These are the arguments that we sort of talked about, where it's from the position that you call them. And then you write your keywords arguments after, where you say the name of your argument, and then you say what it's equal to its sort of default value. So if I don't say anything when I call the function, then I want a to be equal to 2 and b to be equal to 2. And then we return x to the power of a plus y times b. And then you can see if I just define x and y as they are the 2 first positional arguments, I always have to input them into a function. Then it assumes a is 2 and b is 2. So we get 2 to the power 2, 4 plus 4 times 2, 8. So we get 12. And then here I change b. So I'm not going to do the calculate. I'm not going to do the calculations. But then you get a higher number when the b changes, and a higher number when a also changes. You can see it as a task to make sure that's correct. And I think to notice that these keyword arguments, when you define them, always must come after the positional arguments, and also when you call the function. So you cannot write like this, even though you're using the correct name. You cannot call a keyword argument after, before all the positional arguments are called or defined. You can have, if you want multiple arguments but don't know how many multiple arguments you want, you can use the star and double stars. Typically, this could be any name, but typically we call it args for arguments. And then when you define a function, then you say star and then the name of your arguments, and this will be a tuple inside the function. And then what this function just does is it takes an unspecified number of arguments, and then it creates a string, which is just like all the arguments in a row. So here, the arguments I want to input into it are a and b, and then you can see it prints a and b. One way to input arguments into this function is to unpack them using the star again. So we define a tuple, which are a and b, and then we just want to say, okay, I want this tuple to be the positional arguments in my function, and then I just unpack them using the star. But I can also this does the exact same, where I take each element out and say, this is the first argument, this is the second argument, this is the third argument. This is something that you don't really need to use yourselves, because it's pretty easy to get out of it. Args could also have just been a list, but it's probably something that you're gonna see when you're looking at other people's code. So I thought it'd be useful for you to sort of have seen it one time and have it explained to you. You can do the exact same with the keyword arguments. There it's just, you have to think of it like a dictionary instead of a tuple or a list, and you just use double stars instead of one stars, and then it's typically called quarks for keyword arguments. So you define like this. You have something called quarks, which are all the keyword arguments, and then you here we just print the keys and the values, and then you can input any number of keyword arguments you want, like this, and you can also you can also just insert a dictionary directly. So you define it here, and it's the exact same. You have A is equal to something, B is equal to something, C is equal to something, and then you unpack it using this. You should know that you can also sort of unpack dictionary as keyword arguments with functions that have explicitly defined number of keyword arguments. So if I say f of 2.2, and then instead of writing A is equal to 2, B is equal to 2, then I could have it like this, where I write a dictionary where I say A is equal to 2 and B is equal to 3, just to change it up a bit. Sorry, I need to have 2 stars to unpack it like dictionary. And then it says A is equal to 2 and B is equal to 3. And you can also use this quarks and args after some positional arguments or after some other keywords arguments. The same with args. This again, it's something that you're maybe not going to use yourself as you begin to program here in the beginning, but you're likely to see it from other people when you're reading like code that's going to help you writing your own code. So it's good to know what's happening when someone suddenly like unpacks something or define a function with the default number, unspecified number of keyword arguments. Another thing you should note is that a function in Python is an object, so it sort of has a name and can be given to other function as an argument. You can see it sort of like its own variable. So here we define the function f as we have defined it earlier, returning the square of 2 or of x, and here we define a new function which takes an argument x, which here we assume to be an integer, and then it takes a second argument h, which is a function that we call on x, and then we add 1. So what is happening here when we call g of 2 on f is that we go into g, we create this variable temp for temporary, and we say that is the value we get when we call the f function with x as an argument. So we get 4 out here, and then we just add 1, just to show you sort of that we're changing up a bit. But you're outputting the value, and then you can do other calculations. So the key reason for having this is that maybe sometimes we want to add 1 to this function, and sometimes we want to add 1 to another function. So you can have here that this returns x times 2, and then we can also print g of f and the other function. And of course, because it's 2 times 2, then it's gets the same as 2 squared. But yeah, if you times 3, then we get a different number with this function. I think that's all I want to say about function as an object. So this is sort of, it sounds kind of innocuous, but it's really useful that you can sort of have methods or functions which sometimes does something with one function and sometimes does it with another function. I think the key place where we can use it in economic models, if you have some production function or you have sort of a setup for solving an economic model with one production function, and then you want to solve it with a new production function. And if you sort of define how you solve the model very flexibly, then you can just like write the new function and say do the exact same for this new production function. This is where it's sort of like really just wonderful that you can solve basically an entirely new economic model using the code you just written for a different economic model, or the same model but a different production function, which typically changes things a lot. Another thing that sounds innocuous but is very like important to note is scope. Variables and functions can be either local or global in scope, and this scope is sort of it reflects back to the memory and what sort of Python knows at certain points in time. So global variables is something Python remembers basically at all times, like inside, now we're working inside a notebook. So everything you run in the notebook or the code you run will know all of the global variables. And the nice thing about VS Code is that you can see the global variable. You also later, when you learn about debugging, you also learn how to see local variables, but we won't do that at this point in time. But if I press this button up here that says variables, then I can see my variable list, which is the list of all the variables I've defined in the global scope. And this is something that I can always, like any point in time when I write, oh, I want q squared, then Python knows that q is 4, because I've run code earlier where I defined q at some point earlier. Here, yeah, up here, I defined it as 4. And Python remembers that because I've run it in the global scope. But there's also a local scope, which is inside the belly of a function, or just inside a function. So if you define something inside a function, then it only defined in the local scope. For example, for this function. If we go through it orderly, then you can see this first function takes x, and then it returns x to the power of a. And then you can say, okay, what is a? Where's a? It's not inside this function, so it's defined somewhere else. And here we have defined it right here. So it's sort of, a will always be 2. But it's generally a bad idea to do this, because then I have this function, I know, okay, that's x to the power of a, and then I write a lot of code, and maybe I redefine a at some point because I forget about it and I want to use a as a name for something else, and then I call my f function, and suddenly it's a new a, and I haven't like been very explicit about which a I'm using at that point in time. So this is usually a bad idea. A better idea is just to use a default argument and say, okay, I have this function g which takes x, and I want to turn x to the power of a, and typically I want a to be 4. And you can also use it, you can just define a inside the function, then it's always 4 and you can't change it, and it's only defined locally. So you can see why this can be a problem here is I print the output of all my functions, and so here a is equal to 2. I can start, maybe I'll just say a is equal to 4, and then you can see the first time a is equal to the same across the board, but if I then increment the global a, I say a is equals to 5 now, and then I call all 3 functions again, then I can see that the first function has changed because it refers to this global a, while the 2 other functions, which has the default argument or the local a defined here, has not been changed. And it's sort of, there can be some tricky behavior out of this. It's typically important that when you have a function which has values as its argument, then it should be sort of locally defined in the function which values that you're using, like explicitly, if they're coming from arguments or they're just like always the same. Another thing about local and global scope is that when we define this a as equal to 4 inside the function, then we're not changing the global a. So you can see that a is still equal to 5 here, even though we have called this h function as the last function, and there we said a was equal to 4. This is because if we define a new variable inside a function, then it's only defined locally. We could also, like, if we write b here, and then we should also write b here, then when we call this h function, it creates a local variable b, which is only defined locally inside the function, and then returns x to the power of b. But in our variable list here, we don't have any variable that's called b, because it was only defined locally, and Python forgets about it as soon as it's done running this function, or running the code of this function. Yeah. So now I drop this down, and now I have a little task for you, and that's to create your own function, which just returns a person's full name as a string. So here the positional arguments should be the first name of the person and the family name of the person, and then you can have the middle name as an optional keyword argument with empty as a default. So yeah, if you want to pause the video right now and do it, then I'll go through a solution afterwards. Yeah, hopefully now you've given it a go with the task, maybe even completed it as soon as I complete this sentence. And now I want to show you two answers. There are like multiple, always in programming there are multiple ways to do stuff. So if you've done something that outputs the correct answer, then you've done it correctly, for the most part. But here's an example of how to do it. So first name is the first positional argument, family name is the second positional argument, and the middle name is a keyword argument, which is normally just default if you don't say anything. Yeah, so here we just start off by saying the name is equal to first name. So now it's here's sort of Jeppe who created this. So the first name is equal to Jeppe. So first name is just Jeppe. Then if there is a middle name that is not just equal to the default value of nothing, then we also want to add first a space, and then the middle name, and then a space afterwards, and then we add the family name to the string, and then we return the full string. So you can see here, print Jeppe Drodal, economist, then he's going to be called Jeppe economist Drodal. A thing about keyword arguments that this sort of shows is that you can input them as positional arguments sometimes. So normally we write middle name is equal to economist. This is sort of the same in this case because it is the third argument. It's best practice to write it like this, so it's explicit that it's a keyword argument. An alternative answer, which is a bit more advanced but also a bit shorter, is to set up the names as a list of the names. So you create a list called name, where the first element is the first name. If there is a middle name, then the second element is the middle name, and the third element, or second if there's no middle name, is the family name. And then you use this inbuilt method on strings called join on the string of just a space. So you have a space dot join and then the list, and what it does is it joins the element of this list and separating it by this space that you have. So you can see when it's defined like this, then it's just Jeppe space economist Jeppe Drodal. You could also, if you write plus here, then it's Jeppe plus economist plus Drodal. Yeah, this is a bit more advanced way to do it, so you probably didn't guessed how to do that on your first try. But I also want to show you that because sort of sometimes it's easier to have these kind of methods from strings. and it works nicely. Okay, so a summary of what we've done today is that we've looked at functions. They are objects, so they can be arguments inside other functions. They can have multiple, and they can have no arguments, and then they can have no outputs. They can have multiple outputs. The arguments can be positional, and they can be keyword, and sort of they can use local and global variables, or this local global scope, and you should tend to use only local variables inside a function. So you shouldn't rely on global variables because they can change unintentionally. Yeah, that's the main thing for today. I'll also just show you a little extra on functions, but if your brain is totally fried, then just stop the video now and then maybe you can come back to it if you are interested in recursion. So yeah, this little extra thing is just to show that functions can call themselves, and the example here is the Fibonacci sequence, which is just sort of a mathematical sequence that starts with the first two values being 0 and then being 1, and then every subsequent value in the Fibonacci sequence is just the sum of the two previous values. And the way you would define that in Python is sort of straightforward, that you say, okay, if it's the first, if it's Fibonacci n equals 0, then return 0. If it's n is 1, then return 1. So that's the two first here. And then else, just return the function itself of n minus 1 plus n minus 2. And Python understands this like straight away. And that's sort of, I don't know, maybe if it's the first time you see it, then it's obvious, then it will do this, but it's sort of also a bit weird that we're defining something here, and then inside the definition, we are calling back what we are in the middle of defining. Yeah, but it's good to know that Python can do this, and sometimes recursion is the only thing you can do in some situations, typically very mathy situations. It can be very costly, and you will learn more about recursion later, actually, how to make it less costly, because what's happening here, if you call Fibonacci of 7, then the function goes down here, and then it calls Fibonacci of 6 and Fibonacci of 5. And Fibonacci of 6 calls Fibonacci of 5 and Fibonacci of 4, and Fibonacci of 5 calls Fibonacci of 4 and Fibonacci of 3. And you can sort of see that you can have this basically a game theory 3, where you start calling Fibonacci of 7, which calls 2 Fibonacci functions, who each call 2 Fibonacci functions, and sort of here when it's Fibonacci of 7, then you don't get that many operations, but you can see that sort of the operation grows very fast. That's another point. I just wanted you to see sort of that you can call functions can call themselves, and this can be very useful in some cases. Thank you for watching today.